Hello, everybody. Welcome to study our course called Native Architecture. In this lesson 51, we will study the storage, the storage type of the volume and the NFS installation. So volume. Okay, we just see this slide. So on volumes, on disk files in a container are ephemeral, which present some problems for long-travel applications when running in containers, such as this. There are the five containers running in the different Docker host, and we map the volume. We use the localhost storage. Okay, so one problem is the loss of files when a container crashes. The Kubernetes restarts the container, but with a clean state. So we can see here now these pods are using the local files in the host. If the pod fails, the Kubernetes will restart the pod in another host, such as this. If this container failed, and a new container will restart in this container, and it will bind to a new directory, but with the clean state. A second problem occurs when sharing files between containers running together in a pod. Okay, the Kubernetes volume abstraction solves both of these problems. And Docker has a second concept of volumes, though it is somewhat looser and less managed. A Docker volume is a directory on disk. Like this is a directory on the local disk, or in another container. Docker provides volume drivers, but the functionality is somewhat limited. And we can see that. Okay, and the Kubernetes support many types of volumes. A pod can use any number of the types of volume types simultaneous, such as GladFS, NFS, CFS, and so on. Ephemeral volume types have a lifetime of a pod, but persistent volumes exist beyond the lifetime of a pod. Where pod ceases to exist, Kubernetes destroys ephemeral volumes. However, Kubernetes does not destroy persistent volumes. For any kind of volume in a given pod, data is preserved across a container restart. So we can hear. Okay, if we use NFS and mount the NFS across all the loads. So and when a pod ceases to exist, Kubernetes destroys ephemeral volumes. However, Kubernetes does not destroy the persistent volumes. So we can in this NFS. Okay, just we create our NF server in one load. Okay, and the other two loads acted as a client. Okay, they share the same file directory, such as the NFS data. All the three loads can share the same file directory. So first we need to install the NFS server. So we can study it in this configuration file. So first in the master load, we specify it as a NFS server. So we install the NFS caller server in this master node, and we can use this to update the OS and use apt install the NFS caller server. And the second, we create an NFS export directory. We can use the sudo make dir -p and specify the directory. We have created this mntnfs here. So we can here we reload. Just read the. Okay, now we have logged into the master server, and we have created a directory to export. We can list this. Yes, we can here. We just create this file, and we change the ownership of this share this file, this directory as nobody and no group, and change its permissions. We set it to 777. So we can here 777. And okay, and we grant NFS share access to the client systems. So we edit the export file. We can say here this is the export file directory, and this is the IPCIDR we in the of the client loads, and this is the write. It can read and write. Okay, and okay, we save and create, and we export the NFS share directory. Use the export fs-a and restart the NFS caller server. Okay, this is what we need to do in the server load, and now we in the client. So we are in the workload. So first we need to also use to the apt update the package and install the NFS common package. We can use this sudo apt install NFS common and create a NFS mount point on client. So we can here to show the. Yes, we can see also to show the share directory, and also now we need to mount the NFS shell on client system, so we can use the sudo mount and the NF server IP address followed with the shared directory, and this is our local mount point. Okay, we can use this to mount and to share the mountain file. So we can here, this is the mountain point, this is the NFS server IP address, and this is the export share directory, and this is our local mountain point in our client server. Okay, we can do the same in the work tool. Okay, we can also use the dfht to show the mounted file. So we can see here, we also can access this remote NFS server shared file. Okay, so now we do a test. If we just change our directory to this share, and here now we just echo file hello world to hello.txt, and we can check if what will happen in the master node and the work1 node. So in the master node, we just change to the. Okay, we can show this if there exists a file called hello. Yes, it is there is a file named hello text. Like here, we check the content of this file. Yes, it shows that hello world. We can also do that in the second. So first we need to go into the shared directory. Okay, and list all the files in the. Yes, we can see there is also the file exists in this directory. So we just check the content of this. Yes, also its output is hello world. Okay. So in this lesson we have studied the storage, the volume, and install the NFS, and use the NFS as the storage backend. So that's all. Thank you.